Hi there, Mr. Sutton here, bringing you the Algebra 2 6-6 Part 2 homework solutions on exponential and logarithmic equations. In this one, we are focusing on the logarithmic equations. To solve this first problem, since I have one term on each side, I can just raise the base here to each side of the equation. So I'm going to raise 2 to the left and the right side. So we have 2 to this log base 2 stuff equals 2 to the 5th. Over here on the left, the 2 and the log base 2 are going to cancel out, leaving us with just 4x plus 8. On the right side, 2 to the 5th is 32. And let's just solve this as normal now. So we subtract 8, that's 24 over there. And divide by 4, that's going to be x equals 6. Just double checking here, if I plug 6 back in here, I'm not taking the log of 0 or a negative number. So that means that 6 is my final answer. To start this problem off, since I have just a single log on each side, I'm going to raise the base of 10 to both sides here. Or you could alternatively just cancel out the logs since they are the same base. So on the left side, that leaves me with just 7x plus 3. And on the right side, just 38. Subtracting 3, we get 35 over there. Divide by 7, we have x equals 5. And if I plug that back in up here, 7 times 5 plus 3 is a positive number. So we're not taking the log of 0 or a negative. Nothing undefined at x equals 5. So 5 is our answer. On this problem, I've got a single term on each side, so I can go right away to trying to cancel out the log. Since I have base 3, I'm going to raise 3 to both sides of the equation. So 3 to the log base 3 of all of that stuff equals 3 to the second. On the left side, the 3 and log 3 cancel, leaving me with just x squared plus 9x plus 27. On the right side, 3 squared is 9. And since this is just a regular quadratic, let me just move the 9 over to the left and see if I can factor this. So subtracting that gives me 18. And now two things that multiply to 18 and add up to 9. Let me think. 1 and 18 doesn't work. 2 and 9 doesn't work. 3 and 6 works. So x plus 3 and x minus 6, or x plus 6 rather. Zeroing each of these out, I get x equals negative 3 and negative 6. We do need to double check and make sure that we're not getting any zeros or negatives inside the log up here. If I plug in negative 3, this is going to be, let's see here, negative 3 squared is 9. This will be minus 27, but that cancels out with this positive 27. So we just have 9, which is a positive number. So negative 3 is going to be okay. How about negative 6? Negative 6 squared is 36, and this is going to be negative 54. Let me think here. 36 and 27 adds up to something bigger than 54. So this will also come out to a positive number. So nothing is going to be undefined at either x equals negative 3 or negative 6. So these are actually both good answers. Before I try and cancel out any logs on this problem, since I have two terms on one of these sides, I have to merge them into a single term. To do that with these logs that we're adding, I have to multiply the inputs. So I'm going to have log base 2 of x times x minus 2, so that's x squared minus 2x. And then that 3 remains unchanged over there. Now to get rid of this log base 2, I'm going to raise the base of 2 to both sides of the equation. So I've got 2 to the left side equals 2 to the third power. On the left side, the 2 and the log 2 are going to cancel, leaving me with just x squared minus 2x. On the right side, we have 8. And let me see if I can factor this now. Subtracting 8, we get a zeroed out equation. And I'm just looking for things that multiply to negative 8 and add up to negative 2. 1 and 8 doesn't work, but 2 and 4 will work if I have a positive 2 and a negative 4. So x plus 2 and x minus 4 equals 0. Zeroing each of these out, I get x equals negative 2 for that first one and positive 4 for this other one. Are these both good answers? Well, if I plug negative 2 in up here, immediately I'm taking the log of a negative number with this log of x term. So negative 2 is no good. 4 is going to give me a positive here and also here if I do 4 minus 2. So 4 is okay, but negative 2 makes our equation undefined. So we're going to cross that off, and only x equals 4 is a proper answer for this one. For this problem, before I try to cancel out my logs, let me merge those using my log properties. So we can multiply the inputs to these logs since we're adding the logarithms together. So this is going to combine to log base 4 of negative x squared, and then negative x times 10 is negative 10x, all of that equaling 2. To get rid of the log base 4, I'm going to raise the base 4 to both sides of the equation. So we have 4 to the left side here equals 4 squared. On the left side, the log and the 4 cancel, leaving just negative x squared minus 10x. On the right side, 4 squared is 16. And since I've got a quadratic, let me zero this out and see if it's factorable. I'm just going to move stuff over to the right side so I have a positive x squared. So that'll be a positive x squared plus 10x plus 16. And now I need things that multiply to 16 and add up to 10. We've got 1 and 16, which doesn't work. 2 and 8 works if they're both positive. So x plus 2 and x plus 8 equals 0. Zeroing each of these out, I end up with x equals negative 2 and negative 8. Are these both good answers? Well, if I plug negative 2 in up here, negative 2 is actually a positive, so that works. It wouldn't if this had been a positive x in here, but the double negative saved us. And then negative 2 plus 10 is also positive, so that's okay. If I plug negative 8 in here, negative 8 is positive 8, so that's also fine. And negative 8 plus 10 is also positive. So we're not taking the log of a negative or a 0, so nothing is going to be undefined at these answers, which means that we're going to accept both of these answers. They're both good.